This last section, we're going to start learning a couple series that you're going to be using a lot. So we're going to kind of start memorizing some of them. The first example, though, is going back to some old stuff. It asks you to create the first four non-zero terms and the general term for sine of x. And then also go ahead and use the ratio test to find the interval of convergence. So why don't you pause the video, come back, and check your answer. Okay, so I calculated my derivatives. Here's my derivatives. Here are the first four non-zero terms for sine of x. I created my general term here, and then ratio test gives you a limit of 0, which is always less than 1, so interval of convergence is negative infinity to infinity. Okay, now we're going to use this for the next piece in a minute, but let's say I want to do the same thing with this next example, sine of x squared. So the idea is I want to go ahead and create the first couple derivatives. So your first derivative would be cosine of x squared, and don't forget you need a chain rule on the 2x. Now I'm going to go ahead and find the second derivative. Notice you will have to use the product rule. So the derivative first is going to be negative sine of x squared, chain rule 2x, times the second, plus derivative of the second is 2 times the first. Now, if I try to do the third derivative, you'd notice that this becomes very messy. Okay? It's actually pretty easy to create the polynomial for sine of x squared if you know what the sine of x is. So in the previous example, we came up with this. So we figured out that the sine of x, first couple terms, is x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. Instead of going through and finding all the derivatives for sine of x squared, really the only difference is you still have the sine function. The only difference is that x is x squared. You can actually create this series by replacing the x with x squared. So your first term is x squared. Your second term is replace the x with the x squared. And your next term will be just x squared to the 5th over 5 factorial plus dot dot dot. So this is much easier than actually going through and calculating all the derivatives. So the idea is if you know a prior function, you can use that to create more complicated functions. Now, there are 4 functions that you need to memorize. These are the 4. First of all, this one really is just the sum of a geometric. You just want to be able to recognize it. But e to the x, sine of x, and cosine of x, these are the 3 functions you'll be working with a lot. So you want to memorize what these series look like and then work off of it. So you should have a note card with these series written on it. So let's try a couple of problems where we create these series now. And this only works if you're working with a Maclaurin series. So centered at 0. If it's centered somewhere else, you will have to calculate all the derivatives. So we're going to create cosine of square root of x. So what we're going to do is start with cosine of x. So you'll have to look back at your note card for now. So I'm just going to write the first 3 terms. 1 minus x squared over 2 factorial plus x to the 4th over 4 factorial. And I'm going to just copy the general term from here. Okay, so all I did was copy this onto here. Now what the question is asking is to find the cosine of square root of x. So instead of doing this problem by calculating all the derivatives, you can just go ahead and work off of this series here. So this is just saying replace x with square root of x. The 1 doesn't change. If I plug in square root of x in there, this becomes really x, square root of x squared. This stays the same. This becomes this. So there's my first 3 non-zero terms, and you can do the same thing for the general term. So instead of x, just go ahead and replace with square root of x, and there's my new general term. And you can leave it like this. It does not necessarily need to be simplified. Okay, let's try the next one. So this one is asking for e to the x squared minus 1. So again, start with the function, start with this one, and we're going to do the first 4 non-zero terms again. So I'm going to write the first 4 for e to the x. 2 factorial plus x cubed over 3 factorial plus dot dot dot. This is my general term. Okay, so I'm going to do this in 2 steps. First thing it says is let's go ahead and create e to the x squared. So e to the x squared would just mean replacing the x with x squared. So that 1 doesn't change. This becomes x squared. If you want to simplify things, you can. I'm going to just write it like this: x squared squared over 2 factorial plus x cubed over 3 factorial plus dot 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 x to the 2n over x squared over n factorial plus dot dot dot. Now it's also saying, okay, take this entire function and you're going to subtract 1 from it. So I want to create this. What happens if I subtract 1? You're just subtracting that 1 time, so all that happens is this 1 disappears. It doesn't affect the general term. It will affect what that n starts at, but you don't have to tell them what it is. So here's the series. But now, notice, you've lost one of the terms. It's asking for the first 4 non-zero terms, so you do want to add on one more term, which I can do pretty easily. Let's do one last problem. So let's find sine of x over 2. Again, start with the series for sine of x. So sine of x is going to be x minus x cubed over 3 factorial plus x to the 5th over 5 factorial. And again, it's asking for the first 4 terms. And then I'm going to write the general term here. Dot, dot, dot. So sine of x over 2 just means you replace the x with x over 2. So, and I'm not going to simplify anything unless I have to, but I'm just going to leave my answer like this. X over 2 same thing with the general term. And you would get the same answer if you actually calculated all the derivatives, but this is a much simpler way to approach this problem.